Hi, welcome. We're going to see today how to use Tesseract with Python and OpenCV to read text from an image. We're going to see first how to install Tesseract and Pytesseract to work with Python. Then second, we will use Tesseract with a really simple image where the text is really clear to see how fast we can read the text from an image. And third, we will use Tesseract to read text from an image where the text is not so clear, so that we can learn how to tune better the OCR to work with different types of images. If you're ready, let's start. We are now going to see the installation. Here is the official Tesseract documentation, where you can find the instructions for the installation on Linux, different versions of Linux, Ubuntu, different distributions of Ubuntu, Debian, and Raspbian, and other as well. Then there is also for Mac OS and also for Windows. Today we're going to see right now on this video only the one for Windows, but if you want to install Tesseract on Mac on Ubuntu, you can either follow this really clear official documentation, or you can check on my blog where I will put a simplified version of both of them. Let's start with this page where we can find the download file for Windows. They have 32-bit version and 64-bit version. Most likely the new computer, they all support 64-bit, so just let's go with the 64-bit one. And in case you have any problem, then you can just download the 32-bit version. We take this one and let's download this. And while it's downloading, let me quickly explain how the installation process works. There are two main steps. One is to install Tesseract, which is the OCR engine, but installing the engine is not enough. If we especially work with Python and OpenCV, once we install the Tesseract engine, we need to link the engine with Python and OpenCV. So first we install the engine, so let's do that. So we press yes, setup is loading, English or whatever language you want, I agree, install for anyone using this computer. Then language data, we leave everything as it is, except if you want to add additional languages, we can just click here, probably the other one, this one, additional language data, and you can choose which language you want. I will just go with Chinese. English is by default already, so we'll just add as extra Chinese, and we can go further. Tesseract OCR, we leave the default path. You can change it, but I will suggest to leave the default path so that it is easier to follow how to connect later the Pytesseract with the default path. Next, and then finish. First step is done. Then we go, I have PyCharm where we have Python and OpenCV. If you don't have Python and OpenCV, then I have a few tutorials how to install Python and OpenCV, so I will link them on my blog page. And now we have to install Pytesseract. So from PyCharm, I go on settings. Here I have my project, so project and project interpreter, and then all the modules that I have on my Python. These are all the modules that I have, Python 3.7. And then I'm going to add a new library. And then I say Pytesseract, and then install the package. So we already installed Tesseract, which is the engine, and then Pytesseract are the binding Python to link Tesseract with Python, so that we can call Tesseract from Python code. And here the installation went smooth, it was really quick. And so now we can go with our detection. First of all, let's import CV2, then we're going to import numpy as np. And as first step, let's just load the image and nothing else. So the img is equal to cv2.imRead, and here you need to put the title of your image, and I have an image big sleep.jpg, and then let's show this image cv2.imShow emg, and then emg, and cv2.wait key 0 to keep the image open. And that's pretty much what we have to do to show the image. Here is the digitalized image with the text, the big sleep. This is just an image. Now our goal is to read the text from this image. So what we do? First of all, let's import PyTesseract. Import PyTesseract. Then we need to tell PyTesseract where we have our Tesseract installed on our computer. So we can do this by saying pytesseract.tesseract.tesseract.cmd, and this is equals to, now we need to put the path where we have installed the Tesseract engine. And if you left everything as it was the default on the installation, it is for everyone the same path. So we have program files, and then on program files we have to look for Tesseract OCR, and here we have the Tesseract.x somewhere here, so this one. So I'm going to copy the path and then slash Tesseract.x. So you don't need to look for this path. This is the same for everyone if you downloaded the 64-bit version and you install everything like it was as default. Now we need to read the text from the image. So here we have the image. Let's go and read the text. So the text is going to be equals to pytesseract.emg to image to string, and here simply we have to give the image emg. And then let's just print the text. Let's run this one. We take the image, here we see the text. Let's now see how it performed. So let's just take this and let's read it. So the big sleep, and it recognized the capital letters really well, and also here it seems really well detected. It was about 11 o'clock in the morning, mid-October, with the sun not shining, a look of earth, and also how the text is, the formatting of the text is like the original. Here we see maybe some apices that were not in the real text, so there is something, but in general it worked really well. So you can see how we've just like 3 lines. So one, okay, actually 2 lines, because this is the configuration of Tesseract. So we took the image and then we read the text from this image. Then we printed the text. But these are just the 2 lines that we need. Take the image and then give us the text, and here we just printed the text. And of course, this was really simple as we took a really clear image. Let's instead see how it works with some other images that where the text is not so clear, so where the image is not a scan digitalized, but it's just maybe a picture. So let's, I'm going now to take the image. So just, Let's just wait, I'm looking for the image, and here I have the image. So this is a picture that I took from a book. And so what can we notice in this picture? We can notice that there is the page of a book here at the top. We can see that the text is not perfectly in a horizontal line, but here it is following the wave of the book, so it is going up a bit. And also the lighting is much different. Here we have a lot of light, and here there is less light, and then below we have an area where there is nothing, there is no text, so we don't want this area to be recognized as a text. Let's see how the OCR performs with this type of images. So I'm going to load this image into OpenCV. So I will take now the image, which is book page.jpg, and then let's now print the text. Okay, the image is quite big, so this is the size of the original image. It's so big that we don't see half of the image with the height, and this is our text. As you can see, the result is just terrible. It's just, we can say that it didn't work almost at all. What can we do to improve Tesseract? We can approach this problem. We can approach this problem in two different ways. The first is to pre-process the image, so try to apply some filler to the image so that the OCR engine works with an image which is clean, which doesn't have all the things, unnecessary things that are in the image right now. And this is the first method that we can use. And the second is to change the settings of the OCR. We will use both of them, but let's start first with the image preprocessing, which is the one that is going to be the best to have the best results. Let's run this again and let's see how we can approach this. So first of all, I'm going to shrink the size of the image a bit so that we can all see it, and also the OCR will work with smaller text. So EMG is going to be equals to cv2.resize. We're going to resize EMG. We don't specify any size right here. Instead, we're going to specify the size by percentage. So we don't give definite pixels, but we just say fx 0.5. So we're dividing, so multiplying per 0.5, so dividing the width of the image, and also we divide the height of the image. And so let's run this one. Probably already this small change by making the image smaller give us some interesting result. The interesting result is that we're able to read the title of this chapter, design before you implement, you see, and then some of the text that we have below. So we cannot read this first part, but then if the project involves designing a product or service, ensure you have the best possible answer. So let's now see what we have here. So the last part is not detected correctly. Also, what can we see in this image? We see that the change of lighting is affecting the detection in this part. The text is not so clear as it is on this one. So the first step that we did to preprocess the image was to shrink the size of the image. Now, another thing that we are going to make is to convert the image into black and white, or let's say better, grayscale image. It is not black and white yet, it's just grayscale. Gray is going to be equals to cv2.cvt color. We're going to convert what? We're going to convert img cv2 color underscore. We're going to convert the BGR format, so blue, green, and red, which is the default format of OpenCV, to gray. And now, instead of reading the text from the image right away, we're going to read the text from the gray image. And let's run this one. Okay, another improvement right now. Design before you implement, particularly if the project involves designing a product or service. Ensure you have the best possible answer in the design phase before you start implementation. Ensure here still we're not able to read this part where there is some wave, but then we can read the best possible answer in the design phase before you start. And here, of course, we cannot read it. Another 80-20 rule says that 20% of the probe, and it goes on this way. So we see some part is recognized well, but other parts still not so well. And also here it is going to end, so we see the last sentence, the last few words, in some cases retooling, and here it should be this cases retooling, and then we have some extra word that isn't here. So Tesseract is trying to read words also in this part of the image where we don't have any text. Now, how can we approach this problem? There are a few ways, but I will go with the most simple one, and is that of converting the image into black and white. So we converted the image into grayscale. Now we're going to convert exactly into black and white. And to do this, first let me show you the grayscale image so that we can understand better what this is. cv2.imshow gray, and then gray, and let's run this one. Okay, this is the gray image, grayscale image, where we see we have different gradients of gray color. And now our goal is to put a threshold and say below this value is background and above this value is text. And as in this image we have different levels of lightening, we're going to use the adaptive threshold. And I will explain that quickly how it works, but if you want to understand this deeply, I have a few videos about threshold, so the basic threshold to understand what is threshold and also what is adaptive threshold. So from gray we say adaptive threshold is going to be equals to cv2.adaptive threshold. We're going to apply the threshold on gray. The maximum value is 255, so everything below the threshold will be made white. And now we're going to use the method cv2 threshold. We're going to use the adaptive threshold Gaussian, and we will take an area of 91 and a constant of 11. and I will explain this soon. So let's now see what's the result of this adaptive threshold. In show adaptive threshold and then adaptive threshold, and let's run this one. Missing requirement, so something is missing. And yes, I forgot the method. See if it's to.thresh binary, and let's run this one. Okay, the adaptive threshold is really useful to remove the background when we have a background which is not homogeneous, let's put it this way, because it takes a really small area automatically and it finds the best value to put the threshold, to put either the image into black, either white. And we're working with block sizes of 91 pixels, so that's why we did put 91. So I will show what it changes if you put different values. So let's try with 11. This with 11, so the bigger you make it, the more noise we will have, but also the text will be more clear. So here we see that also some parts of the letters are going to be considered as background. So that's why I use a really big area. We can even use bigger than 91. Let's try with like 113, for example. Maybe now there is too much noise, so let's try 85. Okay, this seems a good value. So you see we have the text really clear, but at the same time we were able to remove big part of the background. Second, we have another value which is 11. 11 is a constant value which gets removed from the threshold value. What it means in simple words: the smaller this number, the more noise we have. The bigger this number, the less noise we have, but also there's the chance that with a big number it is going to remove also the text. So if, for example, we use 31, let's try with this, it is deleting some part of the text. If we use a really small number like 3, we have too much noise. So that's why I found these numbers to work well. And anyway, after I've explained this, let's look for the text instead of on the gray image. Let's try looking for the text on the adaptive threshold. And let's run this one. And let's see now what is our result. Design before you implement. Probably the text is a bit better. Of course, there is still some error. I believe 80% of the text is fine, but the other 20%, especially, okay, sorry, not this one, especially on the left side where there is this wave, there is not detected correctly. This was some example of image preprocessing. There are a few more image preprocessing that you can apply. For example, you can put a Gaussian feeder to remove some other noise, or some other morphological transformation to also remove some noise, but I will not go into details not to make this really long. Instead, let's see the settings of the OCR. We have different type of setting, which is pages mode values. I will not go into details about this because my goal right now is just to give beginners a basic understanding of how to use the OCR, but you need to keep them in mind. If, for example, you want to read not a full text, but just a single word, for example, if you want to read the text from a plate, so for plate detection, you will need to use this number 8, so treat the image as a single word. If for example you have just a single line, single text line, and not just a full page, you will use number 7, and this will perform better. Right now we're using number 3, which is for automated page segmentation. So if you want to use these settings and change the page single mode, you can do that adding a line config, and in config you set the PSM, which is the page segmentation mode, and then here you put a value from 0 to 10. By default is 3, and let's try, for example, another mode. Let's try the 4. Assume a single column of text of variable sizes. For example, we can try 4. And then also, when we read the text from Tesseract image to string, we need to add config. Config equals to config, and then we can run this. And let's close this. I see that this works much worse than the number 3, the default method, at least in this case. I see these numbers that are not in the text, that if we use the default value, we don't see. Now, another thing, and the last thing for this tutorial, I want to show how to read the text from different languages. So I'm going to load Chinese text from an image. EMG is going to be Chinese text. I'm going to run this. Fail. So okay, Chinese text.png. So I did put the right name but the wrong format. So let's run this one. So this is the original gray text. This is after the adaptive threshold, not big difference. And this is our result, because by default the OCR is set to the English language. Instead, we need to add lang and then Chinese simplified. So usually it's just 3 letters for the languages. In this case, is also we need to add simplified. So for example, English would be ENG, Italian ITA, other languages now they don't come to my mind, but 3 letters. And let's now use this. Let's see how it works. So I'm not expert in Chinese, I don't know it at all, so I will try just to see if they look the same. So this one, it looks exactly, no, okay, this one looks wrong. This one might be the same, no, okay, even this one looks wrong. This one looks fine. This one seems correct. It didn't perform so well, so we could try also in this case to make the image even smaller. So let's try 0.3 instead of 0.5. I see that the OCR doesn't work so well with really big images, with really big text. I also put this example that don't work really well just to show you that even if you put the OCR in, if you try to use some pre-processing images still to tune it really well. It's not that really simple operation. Instead, I noticed that some other services, like the one I put also a video about OCR API, that they work much better than Tesseract when working with different type of images. So if you want to use the API with such service that you will have to pay to have really good result, then I will also put some link in the description on my blog about that. I hope this was useful for you all. I want to announce right now for everyone who is interested in computer vision that I'm slowly building the academy that will be available in a few months. Hopefully it's a lot of work that I'm putting into it, recording the lessons. Here on YouTube I still put, and I will still keep putting, really simple tutorials, but for everyone who is interested to have much deeper understanding of computer vision, want to learn more advanced topics and deep learning, so the academy is something that you might want to check out. That's all for this tutorial, and see you